Good morning, everyone. As many of you already know, today's lecture, as Professor Chavarria said, is part of the chemist seminars within her course. Before introducing our guest, I'd firstly like to thank her for coming here today, as this represents a big opportunity for all of us to explore a subject which has become, even during the last few decades, one of the core lines of research in archaeological studies, and especially for those of us who are interested specific in this field of study. Now, just a brief introduction. Dr. MULDNER has started her career at Bradford University, where she got her MA degree and her PhD. Am I right? Okay. Correct me if I'm mistaken. I'm sorry. She is a bioarchaeologist specialized in stable isotopes analysis, and her work is mostly concerned with the reconstruction of human and animal diets. She's also a member of the Scientific Archaeology Research Group, which studies through an interdisciplinary approach past environments and populations. So, having said that, I leave it to Dr. MULDNER.
Thank you very much. Good morning, and it's a real pleasure to be here, so thank you for having me. I'll try to speak slowly. Do show up if it doesn't work. So, right. Oh, slowly and into the microphone. Hope this is not too many things to remember at the same time. Right, okay. I've chosen to talk about migration and ethnicity today because it's something we've been working on for a while in sort of the late Roman Britain or the later Roman Empire. I want to start by saying that ethnicity matters. So matters in the real world, not just to archaeologists, it matters to me. I've lived for more than half my adult life now in a different country. I'm German myself. I've lived in Britain for a while, and this is when it really comes home to you how different cultures are. But ethnicity matters even more than it did maybe a year back. We're living at a time, we're living in multi-ethnic societies anyway. We're living at a time of migration. So my home country of Germany has more than 1 million migrants to integrate right now. My other home country of Britain is debating whether to leave the EU, and a lot of that discussion is based on migration and cultural and ethnic divides. So it's something that really matters today, I think. And so the question is, of course, that we as archaeologists should also ask ourselves is to what extent can we provide some lessons from the past, and to what extent this has been there before and people have lived through it or not, with what kind of consequences. Thank you. I do often shout, so I'm a little bit concerned that I'm going to drown you all out. But the history of ethnicity in archaeology is, of course, a long one. So really started off in the 19th century with the birth of the nation states, when people were trying to give themselves this common identity, if you will. And in archaeology especially, it then led to this Gustav Kosinna's infamous now Kulturkreis theory, which was very much concerned with sort of very static ethnicities or nationalities that were living in certain areas and defined by their material culture, and was then, of course, used to sort of claim territories, in this case especially claim territories to the east for Germany. So that has tainted the whole thing a bit. And just because I'm going to talk about bioarchaeology here a bit, of course bioarchaeology wasn't outside of that. So this whole scientific racism, so craniometrics and defining people by sort of the dimensions of their skulls, and using that also to sort of look at territorial boundaries, was very much a part of that. Today, of course, we have a different concept of ethnicity. So recent approaches are very much informed by cultural anthropology or ethnoarchaeology, sociology, and they recognize that ethnicity is just one aspect of very complex cultural identity. So I'm more than my German ethnicity, which isn't quite German anymore anyway, because I've lived in the UK for quite a while. I'm North German. I was born in Western Germany, but I'm also a woman. I'm of a certain age. I've grown up in a certain class, so I'm very much sort of a part of that. It's also something dynamic. It might change over a lifetime, and relationships with material culture are, of course, incredibly complex. So if you looked at my material culture now, you could probably tell I'm not quite British. Whether you could tell I'm German, that's another matter. And so I put you a quote here, a definition of ethnicity from Wikipedia, which you're never supposed to do for students. Actually, it's the best one. It's still the best one I can find. If anybody knows where that is plagiarized from, something I can cite, that would actually be quite nice. But I like about that here, ethnicity is very much also an imagined thing. So you might imagine you have common cultural roots. You might imagine you have common ancestry. And it might also be shaped by your experience. But where does that leave sort of archaeologists and ethnicity and material culture? For a long time was sort of this nihilism, there's nothing we can do anyway, so burial right to some extent is meaningless. Put up a quote here by some eminent Roman burial archaeologist from Britain. This is John Pierce, and he says, well, views about migration that are inferred in this case from material culture and burial right are understandable. What we are still confronted with in the archaeological record are some individuals that are buried in a style that does not quite fit in where they are buried, and that does seem to reminisce, that does seem to have parallels elsewhere. So what are we going to do with them? And as archaeologists, we also want to know what is up with them, want to explain that, and this is also why approaches like the ones I'm going to be talking about, sort of bioarchaeological approaches or biomolecular approaches, such as bone chemistry, isotope analysis, that is my field, so I'm going to be talking mostly about that, but also more recently DNA analysis, and I'm going to talk about a recent study I was involved in to also give you some idea of the future there as far as I see it, if you will. But this is one of the reasons why people were so excited when these methods first came online, just because they were promising to offer us definitive answers, that we could tell whether somebody might be a migrant or not. So we're going to look at that a little bit more closely here as well. But why would you choose to look at migration and ethnicity in the Roman Empire? I like this map for this purpose because I think it really says it all. So if you look, you'll be much more familiar with this one than I am. But if you look at the extent of the Roman Empire, if you think about the countries today that it encircled, the cultures, the languages, the religions, it would have been much more diverse even in antiquity, when we weren't all watching the same TV programs and there wasn't sort of so much globalization. So looking at sort of mixing of cultures in this particular context is particularly exciting and promising as well, because you could expect quite stark cultural contrasts, and importantly for my field, isotope analysis, also quite stark environmental contrasts that might show up in the isotopic record. We're looking at Roman Britain, simply because, well, I lived there, so I live in Britain, so it's convenient. So in case you're not familiar with it, so Claudian invasion, 43 AD, and it came to an end sort of around 450, so the 5th century is a little bit murky in terms of that. We know that people migrated to Roman Britain from across the empire. This here is possibly the most famous example. Anybody seen it before? Tombstone of Regina. So it's a 2nd century tombstone of a woman who was buried south Shields on Hadrian's Wall. She herself was actually British, a British freedwoman from a southern tribe, which might make her interesting already that she got a Roman tombstone, but it's even more interesting who built her the tombstone. This was her husband, and he identifies himself as Byratus of Palmyra. Usually I ask now where Palmyra is, and these days, unfortunately, sort of we all know. So he's from eastern Syria. He was wedded enough to, or proud enough of his heritage to actually, there are two inscriptions here. There's the Latin inscription, and then below that might just be able, sort of at the lowest margin, you might just be able to see that he's actually, sort of the whole thing is written in Palmyran again. So very much, and the questions we might ask is what kind of couple were they, what language did they speak, what foods did they eat? So these are the kind of questions also that we're quite interested in there. The sort of project that I'm working on with colleagues in Reading, especially my colleague Hella Eckert, a fellow German and Roman archaeologist, my colleague Mary Lewis, who's a paleopathologist. We termed it at the time Diaspora Communities in Roman Britain, simply because it was funded, the start of it was funded by an initiative called Diasporas, Migrations and Identities. What we are looking for there is looking at integrating bioarchaeological and burial rite evidence and other artifactual evidence in order to explore diversity in Romano-British populations, explore life histories and also sort of complex identities of migrants in Roman Britain. And that is quite, might say it's not so much an agenda, it's more something that we set out to do because we found that the public image of Roman Britain is very white. Sort of, even though there were people who might have come over, it might have been these Italian soldiers, but it wasn't very diverse. And so we are looking to change the perception by looking also at individual case histories. And you might have heard about the Ivory Bangle Lady of York, so a very rich female burial from Roman York, and sort of craniomorphometric, so forensic analysis has demonstrated that she was most likely mixed race. And so that is something that here's a reconstruction we had done for our project. So, and even though that AHRC, Arts and Humanities Research Council project is now finished, we are also continuing with that, looking at other sites. And I want to show you some of that work and also how some of it has changed. Now, Alexandra told me you're all completely on top, how isotopes, on top of how isotopes work. Is that correct? So I'm gonna do a very light touch introduction here. Generally, the basic principle of all bone chemistry methods is you are what you eat. And that means that all our body tissues, including your teeth and your bones, or all your skeletal tissues, are synthesized from the basic molecular components of the foods that you eat and the water that you drink. So whilst you're sitting there, sort of digesting your breakfast, I hope you all had breakfast, so your body is busy breaking down that food, not just to produce energy, but also to repair your body tissues, to make your hair grow, to renew your skin, but also to slowly renew your bones. Now, different foods and different environments have what we might term isotopic signatures. So isotopes are different forms of the same element that vary systematically between different environments. And with the food and the drink, we are actually incorporating those signatures into our skeletons. So we have signatures that allow us to infer the food and the drink we had in our bones. The trick in bone chemistry analysis is to get that out, to be able to read those signatures. And that's where sometimes it gets a little bit tricky. But we understand the rules relatively well. I work a lot on diet, and those will be familiar with that, mostly carbon and nitrogen isotopes in diet, so they reflect in bone collagen, mostly the main sources of dietary protein. It's not a very detailed indicator of diet. Mostly we can tell apart sort of very basic foods, terrestrial C3, so the kind of foods we have here from marine foods, C3 plants, mostly plants that are adapted to temperate environments, from C4 plants. I'm going to talk about C4 plants later on, and then plant versus animal protein. It's not, if you think about zooarchaeology, for instance, and what kind of detail that gives us, this isn't a lot, but we can do it for individuals, and that makes it very powerful, and I hope you will agree at the end. The other isotopic systems I'm working on are isotopes for reconstructing mobility, and the most widely applied ones there are oxygen and strontium. So oxygen tracks water intake mostly, and because water varies, rainwater varies according to climate and according to geographical location, we get an indication of where, if somebody drank local water, of where somebody was. We're analyzing teeth here, so because they preserve a childhood signature, and we can contrast that with isotopes of strontium. So very different isotopic system, and that tracks geology and mostly bedrock, but there are other things. In Britain, for instance, we have a lot of marine strontium on the soils because it rains a lot, and well, that's ultimately from seawater. But what I'm concerned with here in my talk today is mostly what has been termed intrusive burials in late Roman Britain, and those are, sorry, it's a little bit cut off. It's cut off here, so apologies for that. So those are, and this is a term coined by Clark, 1979, and those basically burials that do not quite fit in with the British burial rite. Most prominently, those are those burials here that have crossbow brooches and belt fittings, so which have been hypothesized to be officials or soldiers from the continent, sort of Germanic element in the widest sense in the late Roman army. But there's also other burials that have certain beads, for instance. He hypothesized that because in Britain people were mostly buried unclothed, so if ornaments were worn, if personal ornaments were worn, so that indicates that somebody was clothed, that would indicate an intrusive burial rite. Gonna look at that. Some of you looking at me critically, you're quite right to think that. But this was for a while, people looked at that. This has been criticized by archaeologists quite a bit. So one thing that we wanted to test was to what extent these ideas of intrusive burial rite, to what extent that would map on to diverse geographical origins. And this was published quite a while ago now. So Langhills at Winchester is one of the famous late Roman burial grounds to look at here, generally because it has a lot of, relatively lot of burials that have intrusive inventories. This is the one where Clark also worked, where Clark developed his criteria on. So, and what we had people do here, so archaeologists, there was a new excavation, another 300 burials, and we asked the archaeologists who were working on them to sort of pick out individuals that were local according to Clark's criteria and that were intrusive according to Clark's criteria, and then there's also some deviant burials. The way this works in oxygen and strontium isotope analysis, which is what I'm showing you here. So Winchester is quite nice because we can define the local environment in terms of strontium really well. It's on chalky substrate, so we're also in this case usually doing a survey of environmental samples to help us there. So this is the range of strontium isotopes that we would expect from people local to Winchester or the general region in this case. And then we put a lot of work in at the time to define Britain as an island, to define, well, you knew that, to define what might be the oxygen isotope signature of somebody who grew up in Britain on British water. So we put a lot of work in, and this is how it goes in science. At the time, it was the best estimate, and we had 48 samples of presumed British people to go on there, and this is why I'm showing you that here and why I present an update. If you actually know the paper since then, this has been revised. So when we had 48 samples, now there are 615. That a lot of them are the samples we actually did for the Diaspora project, which has changed things quite a bit in this case, and you see there's a much wider range here. Importantly, and we're going to come back to that point as well towards the end, this range is not exclusive to Britain. It overlaps with large parts of Western Europe and even the Northern Mediterranean. So that is one thing. Isotopes do not actually tell us where somebody is from. It's mostly allows us to say whether where somebody is from is consistent with the place they were buried, and if it's not, they were definitely not from there, but if it is, it's merely the simplest explanation that this is where they are from. They might be from somewhere with a very similar environment. It's a very busy graph, so I'm going to sort of cut that up for you a little bit. Well, first, I guess I have another slide. So in this case, it is a very busy graph, and you might take a while to look at it, but what is immediately obvious, there's no simple correlation here between burial rite and geographical origin. So it doesn't map on terribly well. The first group to look at is what has been termed sort of the deviant burials. It's a little bit misleading in this case. So deviant are burials that do not conform, in this case, to any Roman burial rites. So they are prone burials and crouched burials. And this is thought to be a continuity of an earlier, possibly British, Iron Age British burial rite. What is interesting about these people is that they are actually the least diverse group. They are quite a close group. Most of them are local, and it's even clearer now with our wider range of oxygen isotopes. There's only one here who really stands out. So most of the others are from, this is the strontium isotope map of Britain. The others are all from blue, is where Winchester is, so it could be anywhere in the blue or green. This is large parts of Britain. This one up here is at least from one of the yellow areas, and you could argue sort of could even go higher if there's a mixing going on. So, and he's the only one out, but there's no indication that they are not from Britain in this case. It was a he, I'm pretty sure. I'm going to take this group out, but this is already quite interesting, I think. I'm going to take this group out and now focus on what the locals and the intrusive burials, just to keep the graph a little bit cluttered. And if we look at that in more detail, we can actually see that there are quite varied relationships between burial rite and geographical origins. Where it works quite well is actually the samples, the burials with the crossbow brooches and the belt fittings. Incidentally, they are all from the earlier excavations, so that was published by Evans et al. In 2006, and those were actually the burials that Clark developed his criteria on. You can't, at the moment, they aren't available for sampling. But here you can see there were 4 burials with crossbow brooches, and none of them is local to Winchester. A lot of them have sort of colder oxygen isotope ratios, so that would place them somewhere on the continent. And then there's this one there, so again, would be somewhere at least in the yellow areas on the strontium isotope map, but could be anywhere from the northwest provinces with a similar oxygen isotope ratio to Britain. So this is already quite interesting. We're going to come back to that in a moment. Where it doesn't work so well, actually, are other burials, and these are mostly the female burials here, and a lot of them are identified by certain beads, and whether bead strings were worn, whether they had several bracelets, all sorts of criteria that do not map on so well, and this is where it really doesn't work so well. So one of them here is one of the women is actually not from Britain, we can say that, but the others might well be local. So this is where it doesn't, it's already much more complicated here. One problem that becomes immediately apparent is actually that a number of our intrusive burials are actually non-adults. So, so children, sort of anyone from 16 and below. And this is actually something that archaeologists have noted, is that the strongest correlation of grave furnishings is actually with age. So it's especially young women who have a lot of beads, and it's especially children who tend to have whole inventories. And you can see the ones, there's a number of children in there, and they are marked with a little dark triangle, and that means they are early forming teeth, so we can't quite trust the oxygen isotope ratio. They might be a little bit higher than they should be, because there's a breastfeeding effect if the tooth formed when that individual was still breastfeeding. So that is something we have to work with. What we can't say, so they look local, they're children, they might not have migrated anyway, so, and we are effectively there. They could be second generation migrants, and that is actually an argument that has been made about this one here in particular, quite an interesting case. So she had a bracelet, which is actually a British made bracelet. She had these, again, she had these golden glass beads, and a lot of them, and they are mostly found in Eastern Europe. But then there's also an argument, we find them mostly in Eastern Europe because this is where people like to be buried with these things. So there's a bias here anyway. So, but the isotopes do not help us here in this case to say whether somebody is second generation. The DNA actually might, and DNA hasn't been done on these. But sort of the final group to look at is the supposed locals, and quite a few of the locals were not necessarily from Winchester, although not a lot of them were necessarily also from abroad. I'd like to pick out this guy here, he's my favorite. So, and looked local in this case, even though he had a belt buckle. So he was classed local. This is a very typically British belt buckle. So they didn't, it was made in Britain, it's in the insular style, and also, and these are sort of Clark's criteria, it was placed in the grave, sort of there was a knife also that was, or a dagger that was placed in the grave rather than worn, so they, according to Clark's criteria, they are local. He clearly is not. I also have dietary data I'm not showing you here. He definitely changed his diet very dramatically between his childhood and adulthood as well. So that is a very nice indication that he's not local as well. But that also makes us rethink this idea that people would necessarily stand out. Well, clearly something was important to him, and if you look at the belt buckle, it reminisces sort of, it has certain parallels to those military belts, if you will, even though it's not quite the same. Maybe that was important. Maybe it was sort of something that he liked wearing because it reminded him of that. Right. What we learned from Blank Hills, and this is the biggest study still on a cemetery like this, is so we have diverse origins. I didn't go into that, but this is also the only site where we have males and females migrating. Otherwise, it's often a lot of males. That also has to do, there's simply more males in Roman cemeteries, in Romano-British cemeteries, and they often have the more interesting goodies. There's no easy correlation between archaeological and isotopic evidence, but why should there be if ethnicity is such a complex thing and the relation to material culture even more? We might have second generation migrants, but we also might have things like integration, hybrid identities going on. But what has also been shown is that these over-intricate schemes, well, Clark has been criticized before for identifying migrants. did not really pay off. There were certain artifacts, so the crossbow brooches seemed to work quite well, but whether they were worn or unworn didn't seem to matter in this case, and also sort of certain styles and places of manufacture. Also, and this is something, I'm a German archaeologist, that's the only thing I started my archaeology in Germany. Actually, my first degree is from Bonn University, so I did a lot of burial archaeology in my time, and it was all about, oh, this is where this is from. Doesn't seem to matter either, and that's quite interesting as well. But this was sort of the start, and we had a chance to go back and examine that a little bit more with another much smaller but very extraordinary late Roman cemetery. So this is Hollowbanks Quarry or Scorton near Catterick. So this is just across the river from Catterick, which is a small town and military fort in northern Britain, north of York. This small cemetery, so has 15 Roman inhumations, and what you see there, this is a larger Anglo-Saxon cemetery, and then set apart from that a small earlier Roman cemetery. Predominantly young males, there's only one female in there, sort of young-ish, so young adults or young middle adults, and no less than 4 crossbow brooches and 7 belt fittings. Altogether there might be about 25 crossbow brooches from all of Britain. Sorry, I'm slowing down. From all of Britain. So this is probably the greatest concentration per burial that we have. So it's long been hypothesized that these might be incomers. Why were they buried separately? Also, there are large burial grounds at Catterick themselves, so why were they buried in a separate place? And this is the study I did next. And we had actually worked as part of the Diaspora project, we had worked on Catterick before, and Catterick proved to be the most boring site you can imagine. There was hardly anybody we did. I can't quite remember how many samples are on here, 20 odd, it's a lot of money, and there were 2 that might possibly be not quite, well, 2 obviously with very high strontium isotope ratios, but another 2 that might seem to have too high oxygen isotope ratios. With the wider oxygen isotope range, they are not so interesting anymore. But the fact, and this is something also to take away, go for some boring sites as well, because this site keeps on giving as a baseline. This might actually be the sort of variation you expect from a mostly local population. And because it's right next to Scotland, it's actually really, really useful. We did a survey, or my postdoc at the time, Carolyn Chenery, did a survey around Catterick in the Vale of York to get down the local range for there. Wider than in Winchester. Choose your sites carefully, this is still okay. And then obviously the oxygen isotope ratio here as well. So the wider one in this case, and we can see most of them are actually definitely sort of very comfortably local. Now if we plot the Scotland people with that, can already see sort of quite a difference here. So the strontium, and this is another important point to make, tells us nothing here, and that is one thing that strontium, it tends to be. This is what Jan Montgomery, very eminent strontium isotope specialist, has termed the strontium of doom range. There are a lot of sort of good agricultural soils that preserve bones well, where humans tend to settle and grow their plants, and they have a very, very similar strontium isotope signature. That doesn't mean they were local, they might be from all sorts of other places, so you need something else to discriminate. And so the oxygen is the most useful here. One thing we should say, the one female we have in here, she seems to have much higher than Britain oxygen isotope ratios. That was an M1 we sampled there, so a first molar, so that was probably affected by the breastfeeding effect. She was teeny tiny, very tiny teeth, so that's my mistake in not being able to tell those teeth apart. Oh my God, this talk is preserved forever, isn't it? But those others, we can actually see there's only 3 that fall within the range of Scorton or Catterick, and the others are all from somewhere cooler, or from a cooler climate, probably continental climate. And that is also something we understand much better about oxygen isotope ratios now, because there are a number of cultural factors that might increase our oxygen isotope ratios. Breastfeeding is one of them, but also drinking beer in the Roman period, possibly drinking wine, sort of eating a lot of stew. They might all increase our oxygen isotope ratios. So higher oxygen isotope ratios are always a little bit difficult. There are very few cultural factors that lower your oxygen isotope ratios, so they are generally much more reliable. And a lot of the Scorton people seem to fall in that. Integrating that with the with the burial rite evidence, first we tried the intrusive versus local after Clark. So these are individuals that have crossbow brooches, and most of them have belts too, and they are worn in the grave, so they are in the correct anatomical position. Doesn't seem to work that well, so let's just ditch this idea that they have to be worn and just look at the crossbow brooches, and that's already, it's not a perfect match, and there's individuals without any grave goods that also seem to fall out of that pattern as well. And others that still seem to be local, but it's a much, much better correlation as well. So we have these 2 that do not quite fit the pattern in this case. They seem to be local even though they have those fittings, or at least they are consistent with local. And this is where talked before, isotopes is an exclusive technique. You can never be necessarily quite sure if they are consistent with local. It's just the easiest explanation, and the best thing to do is throw other proxies at them. And this is where we're coming to the diet. We always do dietary isotopes with them anyway, because it's interesting. And this is also where Catterick keeps on giving. So we have a nice local population here in gray, and we did the bone isotopes for carbon and nitrogen with them. And you can already see the Scorton people, they do not quite fit in there. They are a little bit weird. And we can compare that, well, first of all, we can sort of define the local range for Catterick. This is 3 standard deviations of the Catterick community, so hopefully quite a nice sort of set of people, sort of normally people who lived there all their lives should probably fall in there. A lot of the Scorton people already fall out of that. We can also look at dietary isotopes in dentine and dental tissues to look at diet in childhood. Oops. And this is what we did here. And this is already that you can see with the ones that didn't quite fit, they fit even less now. So we have the one female, as expected. Nitrogen also is affected by breastfeeding, so we have that. But the males, if you look, a number of them changed their diet very, very significantly between childhood and adulthood. This is, importantly, this is a shift in carbon, which is much less temperamental than nitrogen isotopes. So there's something that happened for a lot of them that was quite significant here. So we have Catterick, which is a stationary population, but I'm also giving you here what is 3 standard deviations of Roman Britain, of Romano-British samples. Those are over 1,000 samples now, so it's reasonably robust. Gonna look at that a little bit later, okay? Because we've done some things. Okay. Yeah? Okay. So, and some people still fall out of that range. So that the diet would indicate that at least the move to Catterick, possibly, probably, they also, a number of them definitely also moved to Britain. And the reason why I'm suggesting that is that these very 13C enriched isotopes are actually C4 plants. So a different kind of plant that was available in Britain. In Europe, this is mostly millet, or we have a bit of sorghum as well, but it's mostly millet. Millet didn't grow in Britain. We have a few imports, but very, very little, so it simply wasn't available. So just because they were eating that gives us an indication that they were not from Britain. What I'm quite interested in is also where did they eat millet? And there isn't a lot of data out there, which is so this is Paleobotanic data. It's coming. Right. Okay. Oh, did we lose the? I didn't realize I could still see it. Did we lose the images, the slides? No. Okay. Do you want me to go back? No. Okay. So. This is Paleobotanic data actually from the Neolithic about how far millet had spread. We know from Pliny tells us there are sort of these areas this is where people eat a lot of millet. There isn't a lot of isotope data, or the isotope data we have tends to be still C3. I found one population, this is in Poland, where they actually have where most of the population has isotope data where my people from Scotland would fit in their childhood. I'm not suggesting this is where they are from, but this is a Roman period population. Interestingly, this is sort of pointing us outside of the empire, but now of course we have Mauritius data as well, and this is the first I've seen sort of from the Roman period where they really sort of on the continent where they really fit in. So it's quite interesting. We haven't mapped out the dietary diversity in the Roman Empire yet. We know it's quite diverse, but by this we can also then see my pet theory is they are out from outside the empire, but you know obviously that might not be true. Right. Oh yeah, and here's the reference for that. So, so looking at these two here, so because we had those two burials with crossbow brooches that seem to be local, those are actually these two here. One of them at least is outside 3 standard deviations from Britain, I'm pretty sure moved from there. One had quite a significant shift in diet, but not far outside enough to definitely demonstrate that they were not from Britain. But that leaves us this one, I would say, definitely not from Britain. This one here, sort of question mark. So here's quite important to also do some other isotopes with it. So for Scotland males are mostly foreign, of continental origin. This is what archaeologists had already suggested. They didn't fit in. So it's not always that we're making that up based on material culture. And interestingly, they're also comparable to the Lang Hills males with the crossbow brooches. And this might just be sort of upper status element of what is sort of the multi-ethnic late Roman army, the strong Germanic element, and they just like to demonstrate, that was part of their identity, to sort of demonstrate that in their personal attire. Importantly, from the isotopes, they were not from the same place. It wasn't that they were sort of, well, they might have felt like a community, but they didn't grow up in the same areas necessarily. There's also, and it doesn't matter whether items were worn or placed in the grave for that as well. But we also have people who have no grave goods whatsoever and are still from a site. We have this very discrete cemeteries. You could hypothesize these are officers and possibly their retainers or sort of followers who traveled with them. But it's and that is an important one as well. We can't necessarily say, but there's something to it in terms of isotopes. So lost it a little bit here. Right, okay. So for my third case study, I want to talk about the Headless Romans again. You might have heard about the Headless Romans already. Again, this is something we published a few years back. I want to talk about it now because this is actually the first DNA study sort of the first DNA study on Roman Britain generally, ancient DNA study, but also the first one that I've been involved in. So the Headless Romans, for those of you who haven't heard about it, so this is in York, again in northern England. Site is called Driffield Terrace, much less catchy than the Headless Romans. So actually sort of discrete cemetery within a wider cemetery, the Mount, which is actually a very high status cemetery in Roman York. They are dated at various times from the late 2nd to the 4th century, almost exclusively male, and they actually have heads, otherwise we couldn't have sampled their teeth, but mostly they are decapitated, and often the heads are either, well, they might be decapitated, placed in an anatomical position, or they might be, in this case, here's one, get confused all the time, here's one with a head at his knees. So there's a number of them as well. Several multiple burials, weird burial rites. It's a very, very weird site. So we still don't necessarily know what it all means. So we've done isotope analysis on them at the time. So this is the oxygen strontium isotopes. We've also obviously have done carbon nitrogen isotopes, and my colleague Janet Montgomery, the University of Durham, she also has lead isotopes, and they are very diverse. So we are very sure that quite a few of them are not from York, probably, and not from Britain as well. And you might be able to see it as a different distribution here than other burials from York. This is possibly why DNA people got interested. So this is Rui Martignano. He's doing his PhD with Dan Bradley at Trinity College Dublin, did a DNA study on them. Just as a bit of an introduction, so ancient DNA obviously was for a long time beset by methodological difficulties, and especially ancient human DNA contamination was a huge issue, and that you couldn't necessarily tell contamination from the authentic sequences. Obviously, huge strides have been made, and one of the most important innovations is next generation sequencing. Sequencing technology, which was developed for the biomedical sciences, but is basically sequencing DNA, modern DNA, by chopping them up into very small strands. This is how it works. And ancient DNA people are very smart, and they thought, hang on, our DNA is already chopped up into very short strands. So this is perfect. What this has meant, this kind of technology, is that you can now sequence a huge amount of DNA for very little cost and with very little time. The problem now is more computing all that data. So if you look at that here, keep getting confused. So the first human genome cost several $1 million. Was it $1 billion? And now you can do sort of several in a few days for very little money. And most importantly, also, so you can get whole genome data. That's an amazing amount of information. It also allows people, because for a long time European DNA didn't seem to be differentiated enough to actually tell, for instance, the Romano-British from the Anglo-Saxons coming in. So with that much DNA now, there is a lot more to differentiate. And of course, authentication has also made strides. So these DNA studies are now becoming possible. So this is Rui's paper that I was involved in, just to you can read it, all open access. So just to give you sort of the highlights in terms of the DNA. So they did 7 individuals from Driffield Terrace compared with 1 individual from the pre-Roman Iron Age in Yorkshire and another one from the Anglo-Saxons. Welcome to DNA analysis. From that, you can compute sort of population history or preliminary population history. There's actually another paper published on the same day that provides some more data, and they tell the same story, actually, that a change mostly came in with the Anglo-Saxons. Romano-British people seem to plot with modern Welsh, sort of with people living in modern Wales, which makes sense. So this was always thought of as the refugium, sort of for indigenous people, if you will. Interestingly enough, of the 7 individuals, 6 plotted with, sort of came out as Romano-British, as could be defined. The Anglo-Saxon individual plotted with what are modern Dutch people, and that also makes sense, sort of in terms of sort of Frisia, sort of northern, the North Sea coast, and that is something. The other paper focused more on Anglo-Saxons. That is also something that they come out with. Obviously, these are the first results. One thing in DNA, more results always change things. Well, isotopes, more results always change things. So this is a very interesting paper as it is. There was one individual actually that didn't fit in this case, and that had what came out as a Middle Eastern genome. So that is today most abundant in Syria, Lebanon, and Jordan. So that's really exciting too. These are the samples that they typed for DNA analysis. There's actually a case where it would have been, we weren't involved, neither Janet nor I were involved when the samples were selected. I guess they went by the paper, and also there's restrictions what you can sample in terms of preservation. You're now going for the petrous bone, which is the bone, sort of the inner, the bone that holds the inner ear, if you will. This is where the least contaminated DNA is preserved. The problem is it's not easily accessible. So a lot of them were actually looked local in the first place from the strontium and oxygen isotopes. The diet often was a little bit off, though, so that's quite interesting. Now, the Near Eastern, the one that came out as a Near Eastern ancestry, we had dietary data from bone for him, and he didn't stand out at all. But so with this data, we actually went back and did the strontium and oxygen isotopes as well. And we thought we had sort of, we had the oxygen isotope range for Britain down, and this one, when he came out, he completely sort of showed us he's completely out there. So before, we would have thought that the yellow triangle there, that was sort of very exotic with very high oxygen isotope ratios for Britain. That was the highest actually we ever had. This one, clearly exotic from the DNA, very exotic isotope signature, oxygen isotope signature as well. That's important, of course, because the DNA does not tell us about the life history of an individual, it tells us about their ancestry. With whole genome data, obviously, we could tell if there was a mixture sort of from other places, so which is more likely if they stayed in a place for longer, but we wouldn't necessarily tell what these people did. These isotopes also tell us that they probably grew up abroad, so this fits with something quite hot and quite dry. The oxygen isotope, the strontium isotope could fit for Winchester, not with the oxygen, but this is chalk. Unfortunately, most of the Middle East and the Eastern Mediterranean is also limestone, so would also fit. So in come the dietary isotopes. His childhood diet also turned out to be quite different, very high nitrogen isotopes. And what I've done here, sort of, you can just about see him there. He's sort of the yellow diamond. Can I show him here? Can you see that? There, it's him. And plotted him here with Roman period populations from around the empire, if you will, importantly. So the Near East is what we have in terms of data from the Near East, so where his genome points to. They are incorporated in the red and pinkish colors, so it doesn't fit at all. Doesn't mean, he's probably not from one of these places, he's probably from somewhere where we haven't sampled. If he's from somewhere hot, then the chances are there's no collagen preservation, so it would be difficult to get data. So the best match is at the moment with data from the Nile Valley, from the lower Nile Valley, so from Egypt. That doesn't mean he's from Egypt, it's not what we're suggesting, but we might be looking at a similar environment. And this is also where diet can be really quite useful. The DNA was also useful for, well, useful for so many things, but also for sort of making us look closely at our isotope methodology. As I said before, this guy here sort of previously was the highest oxygen isotope ratio we had from Roman Britain. Even with the new oxygen isotope range, the wider oxygen isotope range, was pretty sure this one at least is a real one, sort of from a hotter area, and actually his genome came back as Romano-British. Now, he might have sort of had Romano-British parents, grew up somewhere hot, and then moved back, but Occam's razor tells us that's probably less likely, then maybe we're a bit wrong with that oxygen isotope ratio. What we don't have a lot is oxygen actually from the western seaboard, where it's warmer, or at least we have higher rainwater isotope values, and this also tells us we shouldn't, even with 600 odd samples, we should never get too confident that we actually know this sort of proper range. And there's other samples, sort of, especially with the diet, said we have 1,200 samples in terms of diet. I really thought we had the Romano-British range down, also in terms of the nitrogen. There's one who falls completely out of that, still comes out as Romano-British. So it's interesting to see how that develops, but it also makes us go back and think about sort of what we know in terms of isotope ranges. So you have to, and this is how it goes in science, you have to constantly be ready to question your own assumptions and revise. You said the data is still good, but our interpretations might change. Oh yeah, and this is this guy. Now, you might have heard about the Headless Romans, gladiators, so that is the thing. The question is, who were these people, sort of terribly chopped up in sort of high spadatus part of the cemetery? Obviously, there could be a military connection. It's a very odd burial rite. We don't know that. So one of the theories is they might be gladiators. It's not completely sort of unfounded. So there have been comparisons with the sort of gladiator cemetery in Ephesus in terms of the trauma. That cemetery, there's actually a tombstone that says, we buried gladiators here, so slightly different. You can read the latest in the DNA paper to what extent sort of so Malinholst from and Anvan Kaffel from York have reassessed the bones. Running out of time here. The most important indicator here is actually sort of, this is a hip bone, and you might see the sort of puncture marks. These are actually meant to be carnivore bite marks. So this is meant to be not from a tiger, possibly a bear, so somebody was chewed there. They're going to reassess that now. So actually, when I wrote the Headless Romans paper that came out in 2011, we kind of came out with, oh, you know, they might be gladiators. The thing is, why not? You know, we tend to be quite skeptical with these things, but yeah, it's possible, and that's exactly where we are now in 2016 as well. So watch this space. Maybe the bite mark analysis will bring something. Okay, I want to finish up by just looking at a strontium and or isotope analysis in general and some critical remarks. I already told you to what extent we have to assess some of our assumptions. So here I plotted all the Romano-British strontium and oxygen isotope data that we have, and the colored individuals, they are all the ones that are intrusive, that have been looked at as intrusive. And one thing, obviously, a lot of them actually fit, but what we also come up with is that there's a very large number of undiagnostic burials. These are thousands of pounds worth of analyses in there, and we can tell not much in terms of they fit Roman Britain, but they might also be from elsewhere. And that gives us sort of, in terms of where we're going now, is sort of oxygen, strontium, we have limitations. So here's an oxygen isotope map of Europe based on rainfall, and you can see here this sort of vast areas of Western Europe, the Mediterranean, they actually have very similar values. Combine that with strontium isotopes, which I already said, we have this range, which is the strontium of doom range, where the majority of individuals that are analyzed fall in, and you have problem of equifinality. So we need to employ as many proxies as we can get, and we need to also develop more. So I've already hopefully showed you the value of employing diet as well. Sulfur obviously is a new one. Janet Montgomery has amazing results with lead, and it actually looks like lead, especially for Roman Britain, because it has there's sort of British lead ore, and that seems to identify individuals that are coming in with a different lead signature quite well. So that is something, unfortunately, lead is even more expensive than strontium. But this is something also for you to take home. Don't just think you're doing 2 isotopes and that's going to tell you everything. Right, might be coming in just an hour. Conclusions. So isotope analysis, and more recently ancient DNA, so we can get the biological background of individuals, and that is life history for the isotopes. So there we can see what an individual did, versus ancestry for the DNA. And ancestry is obviously something the individual might have been aware of their ancestry or not, and that might make for very different decisions, might make for different identities. But what we can do with those, we can contrast them with cultural expressions of identity, for example, the burial rite, and that way get closer to this life experience of these individuals. We are still there. There are no simple correlations of geographical origins and burial rite. Why should we expect that? I'd like to see evidence for integration here, sort of hybrid identities. Call myself a hybrid identity. Other people, this is actually caused a lot of, people don't like it necessarily, especially if you're conservative. So we had a lot of reactions to our work, which were, well, we know what Britain looked like 50 years ago, and there weren't any foreigners. So for late Roman Britain, it's actually the crossbow brooches and those military belts. That seems to work. So it would be interesting to know what is here. So they do come out as continental migrants most often. And sorry if my text, it wasn't blanked out on my slide, on my version of this. So this might be, they do not come from the same place though. So this is maybe a shared military identity, especially in the upper status. And there might also be, I'm not sure what there is the possibly, but I think it might be their possible retainers. We need multi-proxy approaches. It's great that the DNA is coming online now. It's DNA is they often have different aims and objectives from archaeologists. So rewriting the population history of Britain. So, but it was wonderful to work with that. So, hopefully we can do more of that. But also very importantly, we are making a lot of assumptions about sort of their putative homelands based on our isotopic signals, and we don't necessarily have data from there. And that is something where it's important that more comes online, so that we can actually find make more confident assignations in terms of where people have come from, and also where people have definitely not come from. So we can make educated guesses at the moment based on what we think people should look like, but not necessarily yeah, once there is data, it sometimes looks quite different, actually. Right. Thank you very much for your attention. And thank you.
Well, thanks a lot before Roberto finished leading the discussion.
Right.
I would really like to thank you for coming today. It was a wonderful lecture. I've heard you a lot of times, and I really thank you because I think this was really new. You didn't reuse something old, as we always do for students, but you really did something new, super interesting. Thanks so much. I want to tell you, all of you, and I'm going to speak very slowly, the ones who follow the early medieval course, you don't have to care because you know everything about stable isotopes. I will give you the text. She showed us maybe something else. We will continue studying during our course the ethnicity, migration, and other subjects. And for the smaller ones, we are going to talk again and again about these subjects, about the cross-broach, about migrations, about the soldiers, about the crisis, about diet, and about ethnicity. So don't worry, I think it was a wonderful presentation. You know, Professor Muldner? Yeah, well, I studied in Bonn also, so yeah. And what was I going to say? Yeah, she came here, she has come to Padova because tomorrow, I told you, we have the PhD from Maurizio Marinato. He is doing this kind of things. He's doing stable isotopes on Lombard population in Padova. So this kind of difficult, complicated, extraordinary analysis are also being done in our university. And that's a thing you should think about. Maybe in future you become like GUNDULA or like Maurizio. So I think it's very important that from the triennial, from your youngness, you start hearing important things and not just the things we explain you because you are just young. I leave Roberto now the discussion. If you have some questions, just please don't think questions are stupid because you are young. Any question is important, and it can help her also to understand if what she told us is understandable enough, or if there are other things we are interested in. Okay, Roberto?
Thank you very much. Starting, I think this presentation was very interesting by many points of view. Sorry. It's better this way. The thing that struck me most is the quantity of different information we can derive from such analysis. And I would like to ask if there is a certain period of time, I mean, if a period of time has to be long enough to infer such information on migration. I intend if a person comes from one place and moves to another, what would be the time length to appreciate such variations?
It's less about, well, the time that they moved is mostly important for if you have a dietary change, for you have the childhood signal in the teeth, and then if they lived in the new place for long enough and they changed their diet, you would expect the bone to then assimilate. And we had a few of these. So one of the people from Winchester with that insula, with that British buckle, and then that, I like to call him a Syrian migrant, sort of because it's quite topical at the moment, might of course not be true, with the DNA, we would not have picked them out in the bone isotopes. So it's less about, so that is, time in this case is rather not in our favor if they stayed long enough, and we're just looking at the bone which keeps renewing itself. So looking at the teeth, that should preserve the signal from childhood. The key thing for these people to show up is that the environment they have to move from has to be different enough, or that they have to have a different enough diet for us to pick them out. That is the key thing, and that seems to, this is why it actually works really well in the Roman Empire, because we have such very stark differences in environments and in diets, which we are only just starting to sort of map out. So,
thank you very much. Yeah, you answered perfectly my question. I'm sure there's many questions. Just raise your hands and ask, please. Does anybody have questions? Don't be shy. Maurizio?
with status. Yeah, yeah. That is, you're probably familiar with Mike Richards' work on Poundbury. As sort of, that was the first Romano-British cemetery that was analyzed for diet, and there he saw a really sort of nice difference between the high status burials in sort of Roman style lead coffins and mausolea, and the lower status burials in earth graves and normal earth graves, in that the Roman style burials have more fish in their diet, and which might lead us, either it's a status thing or it might just be a Roman thing. If you try to live like a Roman, you know, you might also eat fish, so that's very nice. I've tried that in various places that I've worked in, and I've never seen such nice differences. So we've tried it in York, where, and the stone coffin burials, none of it stood out. There's a lot of reuse of the sarcophagi going on there. There are some smaller sites. One of my students has a site from London now, and there you can see sort of richer furnished burials. They have higher carbon isotope ratios, so there seems to be fish. And Colleen Cummings, who did her PhD in Oxford some years back, she also has another site, Cirencester, I think it was, where she has the same thing. So it seems to be there, just not at every site. But that, you're absolutely right, status also comes in there, so people might have a different diet for status reasons. The ones that I would interpret as migrants are the ones that really stand out. So we have the ones that really sort of are out there, that are statistical outliers. And what we seem to have often when it's a status different is that it's not necessarily two completely discrete distributions. But you're absolutely right to wonder about that.
Some more questions? Anyone?
I have a question.
Okay.
Yeah, just a remark and a question. I want to underline for the students how well Professor Muldner showed the necessity of multidisciplinarity and the using of different science, from the most classical ones, like the objects, studying different objects, comparing it with the anthropological data, then with the isotopes, and then the last newest thing, I didn't know about this data, the DNA. So that's absolutely new and very important. I wanted to ask you, you that have worked so much with isotopes, I was not deluded, but a little bit like, wow, so many years making isotopes, and the results, and this is also very important, the results are complicated, because life at that time, like, is it
one thing where I'm a little bit unhappy with the DNA paper because it now comes across, they sampled 7 individuals, not necessarily ones that we had best evidence for that they were foreigners, and they came out as Romano-British, and now it's like, oh yeah, most of this was mostly locals in that cemetery. There's 80 odd people in that cemetery, so probably not. I don't think it gives us all the answers. It's amazing to have that. It helps us also understand the isotopes, but it's also important to say it's 2 different things. Ancestry is something you may not even be aware of. As I said, with the whole genome data, it's much easier now to find some admixture. So if both your parents are foreigners, then you might more easily be aware of that, obviously, provided you knew your parents. But that is something completely different from the isotopes, where we actually see the life experience of that particular individual and whether they move or not, and whether they died relatively soon after they moved. So it's strongest sort of with both. And I've been teaching, DNA, ancient DNA for 10 years now as well. And so I'm not a specialist, but I can see how it changed as well. And often they change their minds as well. It's the same thing. So at the moment, there's altogether 15 samples now with that other paper to look at the history of sort of Iron Age to Anglo-Saxon England, and it looked like nothing much changed in the Roman period, and things changed in the Anglo-Saxon period in terms of genetic makeup, so more people coming over then, but those are such few samples that it might just change with bigger studies, and that is something that happens in DNA analysis as well. They change their mind. We change our minds. It's science, you know, you move on. Archaeology as well. They just change their mind in nature and science, you know, and we do it in the Journal of Archaeological Science. So I think that's the thing. It's the most important thing is to have everything together, and to also, and that is really important as well, you don't have to know about all of this yourself. Work with people. And that is the best. Don't necessarily try to do it all yourself. Try to be good at what you're good at. So, but yeah. It's very exciting, and we're only at the start of what ancient DNA can do, but it's not the give-all, end-all. I don't think so.
We are waiting for the results of Patrick Geary's analysis on Lombards. I've heard he has done hundreds or thousands of analyses. It could be very useful for us in order to compare that, as you said. Let's see what are the results and how can everybody use them.
Yeah.
Okay, I would say Roberto, if nobody else.
I'm interested in the application of all these wonderful analysis to another kind of period, first imperial age, synergy are characterized by cremation. So how we can make something later?
Yeah, the problem is with cremations, as you know, so the heat destroys the DNA, and it also changes where it destroys the collagen that we're using for the diet, and it also changes the isotope where it makes bones more prone to diagenesis, for taking up elements from the soil, so it makes a difference there. There are some sort of new results. Christoph Snöpp, he just completed a PhD in Oxford, and he looked at strontium in cremations, and he found in calcined bone, so completely calcinated bone, that strontium actually seems to be preserved. The biogenic strontium seems to be preserved simply because it's very dense and it's enclosed, and it can't be changed. So you need something that is really completely calcinated. The teeth don't work, and obviously that is a problem. So normally we can't use bones for strontium because they are always contaminated by burial soil strontium. There are different views on whether you can get the contamination out, and some people think yes, or don't necessarily think so, but obviously strontium in bones is different because we might have missed, even if they migrated, we might miss the event. There's the one paper, so there's experimental results. It's very nice work. What they didn't necessarily do is look at strontium concentrations. So I would say watch this space. Oxygen is a different question, whether that would work, doesn't work there's different ways of measuring oxygen, doesn't work in the carbonate. There's an academic argument why it might work in bone phosphate, because that is a chemical bond that is quite resistant to heat, but people have tried that experimentally quite early, while back in Britain, and it didn't seem to work. So I think it's about more work to be done. It might not be quite as hopeless, and things, in my experience, things always move on. So things we thought, God, when I first started teaching, it was really easy teaching ancient human DNA because I could just say, don't bother, it's all contamination anyway. It's a lot more work now. So things do move on, so we're not quite there.